everyone. Now we are going to discuss about the Unit 3 laser topic. This subject PH 3151 Engineering Physics paper. Let's consider this lecture 3. Discuss about the ND-YAG laser. That is one of the laser device. ND-YAG abbreviation neodymium yttrium aluminum garnet laser. This topic now presented by Dr. P. Sarita, Assistant Professor, Department of Physics, Government College of Engineering, Tanjavur. What are the major three components of laser production? First one, active medium, that is for active center. Your material consider this active medium. And second one, pumping action. This ND-YAG laser production using optical pumping. This is xenon flash tube are used. And third, components for optical resonator, that is high reflector, and another one is output for low reflector. One for 100% reflecting mirror, another one for partially reflecting mirror. This partially reflecting mirror pathway only, we got to produce this laser beam. Now already you know, I have explained this laser principle. First one, spontaneous absorption principle. This ground state atoms presented here. One photon energy absorbed after these atoms go to the exit state. This exit state atoms without help automatically returns to the ground state timing. One photon energies are emitted. That is spontaneous emission process. Third one process, simulated emission process only, laser beams are produced. The ground state atoms presented here, with the help of external energies, these atoms go to the exit state. This exit state, one photon energy absorbed after this atoms returns timing, two photon light beams are emitted. So multiplication of the light beams are emitted, that is laser beams are producing. Okay, this ND-YAG laser, that is you got to consider the metastable. Exit state atoms returns to the metastable. Metastable to ground state return timing only. Laser beams are produced. So laser action. This picture represents the laser action principle. So ground state atoms. This exit state atom presented here. The ground state atom go to the exit state, and then one photon light beams are absorbed. These atoms, okay, and return to the metastable here. Metastable for particular time only stable here, 10 power 3 second. Exit state lifetime 10 power minus 7 second. Suddenly these are returned to the metastable. And metastable for 10 power minus 3 seconds after suddenly return to the ground state timing, laser beams are emitted. And this for laser action, multiplication for photon energies are emitted. Okay, these are one photon energy instant after one atom return timing, two photons are emitted. Two atoms are return timing, four photons are emitted. Four atoms absorbed this 4 photon energy. This is 4 atoms returns to the ground state timing. 8 multiplication of photon energies are emitted. That is laser beam. This process is known as laser action. This principle occur inside the laser production. And ND-YAG laser, neodymium yttrium aluminum garnet, that is considered the active medium, this compound ND-YAG. Pumping process, optical pumping method following. Excitation of photon energy, that is using the lamp xenon flash tube. The xenon flash tube, emission of the photon, and output of wavelength value 1.064 micrometer. Next, construction of the ND-YAG laser production. We have to consider this for elliptical cavity, cylindrical shape of the model. Consider the elliptical cavity, both end for surface, both surface for, okay, elliptical surface consider, and in center medium, that is active center, active medium. This active medium for consider the rod material. The rod is made up of this ND-YAG rod, that is yttrium aluminum garnet doped with neodymium material. This yttrium aluminum garnet doped with neodymium material. This is center, this medium consider. And then inside bottom of the surface, optical pumping method, xenon flash tube using. This xenon flash tube, both ends are for connection to the power supply and resistance also. Okay, first we have to consider this for both reflecting mirror. One side for 100% reflecting mirror, another side for partially reflecting mirror. So polished surface. Okay, sodium chloride, bromide, or any one for optical mirror coating. This for both surface. Okay, this material for reaction inside the active medium. The working principle of the ND-YAG laser. First, power supply switched on, control the resistance, current flow. This optical pumping source. The xenon flash tube are on, switched on. The lamp sources are, light sources are emitted. Emission of photon energy. This emission of photon energy incident on this ND-YAG rod. Neodymium aluminum garnet doped with neodymium element. So this element reacted. This yttrium aluminum Y3 plus aluminum material for replaced. Only neodymium material only return to the ground state. The neodymium returns to the ground state timing. Emission of laser beam. The laser beam emitted only for 50% partially reflecting mirror only. We go to pass this laser beam. And consider this energy level diagram. It's a ground state energy level. Yttrium, aluminum garnet and neodymium materials are considered. And ground state energy level E0, and then another level E1, E2, and E2 exit state level. Another exit state maximum highest energy level for E3. So two elements are go to the exit state Nd3 plus and then Y3 plus yttrium. Okay, this is 3 plus ions go to the exit state. The exit state, one photon energy absorbed after this Nd3 plus ions spontaneous emission process. This exit state to the metastable come here. This metastable E2 level, a particular seconds only stable here, 10 power minus 3 seconds. Suddenly, this Nd3 plus ions return to the ground state timing. Two light beams are emitted. That is, laser beams are producing. This laser output wavelength for 1.064 micrometer. And the remaining elements, Y3 plus ions and Nd3 plus ions for particular elements only without non-radiative decay, without changes, and return to the ground state atoms. And applications of the ND-YAG laser, major 3 applications are given. First one, endoscopy, medical field. This endoscopy method, END process using. And another one for communication process, satellite communications wise, would analyze. And then earthquake and then vibration of the material analyzed. So LiDAR, LiDAR and sonar, this navigations inside this material for used. ND-YAG laser used. That's all. Thank you one and all.